In the last video, we looked at regular expressions and how to write them and how they worked and what their syntax was. In this video, we're going to specifically look at how to use regular expressions in Python. And in particular, what we're going to do is work our way up to this meme, which floats around the internet all the time. It surfaces every once in a while. You'll see this pop up. Namely that facetious is the only word in the English language that uses all of the vowels in order. And I want to know whether that's true or not. We have a series of lexicons that we can look at, and if we know how to write regular expressions in Python, we can ask that question and answer it legitimately. Well, as you might expect in Python, there are two parts to this regular expression equation. Number one is that the regular expression module in Python is necessary before we can start playing with regular expressions. It has a really simple name. It's just called RE. And so one of the first things that we have to do when we're going to play with regular expressions in Python is to import RE. Again, just to repeat everything we've said before, Python runs lean and mean, and so it just hedges its bets, and it says, hey, look, you're not going to need regular expressions today, so I'm not going to load any of that stuff for you. So we have to tell it to load that. The second part, though, and again, you might expect this, is that when we create a regular expression in Python, it actually becomes an object, just like everything else. And so we will create an object with the re.compile method, and that will produce for us a regular expression object. Here I put it into a kind of a fake variable called pattern, and I've italicized that to suggest that you should just create your own variable name there. And we'll do this when we get to the Python a bit later. What I send to the compile method is actually a string that contains the regular expression itself. So this is a great place where we can go back to, say, regex 101, and we can debug and craft our regular expression so that when we get it just right, we can copy and paste it here in our Python code and send it to re.compile to produce an object. Now, once that object is created, we can call a number of different methods on that object in order to get what we want. So I'll just do one first one here is the match method. So what we will do is send to match a target string, and then that will return to us a match object if there is a match in there. So we can start to look for groups, and we can do all kinds of things. Now, I'll be really honest, I don't use match very often because match only searches at the very beginning of the target string. So as you can see here, it's kind of the same thing as using a regular expression with the up arrow anchor in it. That is to say that the regular expression will be anchored to the very beginning of the string. So I'll be honest, I don't use match very often, and the one that you use much more often is search. Because search will look through the entire string to find out where that regular expression matches. And the same thing, if it does, we'll get back a match object. And I'll talk about those in a minute. Or none. And none, remember, is kind of falsy, right? So if I'm doing this in some sort of a Boolean test, perhaps, and I get none back, that tells me that there was no match there. Now, the one dilemma about search is, as you can see here, it stops after it finds the first match. That's not always what I want. In the last video, we started playing with groups, for example, and we were seeing that groups might match anywhere throughout the string. So the one that I think is probably used the most often of anything is find all. And that finds every occurrence of that regular expression in the target string. And it doesn't matter if we've got groups in there or what. It will just continue searching through that string to find everything that we want. There's a version of that here called find iter, and that gives us an iterable collection. And so that might be an option for you too. But just to repeat, the two that I use the most often are search, which is going to look through the entire string to find everything, and find all. There you go. Right here. I can't highlight that, but there you go. Now we can do all kinds of other things with the regular expression object in Python too. The split down here allows us to split a string based on maybe some really complicated regular expressions. This is terrific for cleaning data if you need that. And there's also a substitute here, right? The strings, remember, strings have a method called replace, but in regular expressions there is a substitute or sub. And so it's going to replace everything that is a regular expression match with a replacement string in that target. Now, the one thing I'd like to point out here before we scroll down a little bit is that, at least in this handout that I've given you that's up on eClass, it's really important to remember what is returned by these various methods, because you'll notice they are not all the same thing. So, match and search return to you a match object. We'll talk about that in just a minute. Find iter gives you an iterable collection. Find all gives you a list. Split gives you a list. Pattern and sub give you a string. So one of the cautions I would give you about using regular expressions in Python is to remember that you will not always get the same type of object back. It will return to you different kinds of objects, and so you just have to remember what those are. Now, let's imagine that I'm using a match or search, which are really quite popular. I am going to get back a match object. Not surprisingly, it's Python. It's objects all the way down. Why the match object is important is because it has these two methods, group and groups, plural. So if you are extracting data using groups, and if you look back at the last video, we were doing that, this is how you would extract the bit of data or the part of the string that the regular expression matches in a group. And I mentioned in that last video that you can figure out the number of your group by counting the number of left-hand parentheses. That is really important because when I ask for a group, I have to tell Python which group number I want. Now, if I don't send any number, I will get 0, and you'll notice here, group 0 is the entire match wholly. So I could get back the entire match if I wanted group 0. But you'll notice in the regular expression, in the match object here, I can get all kinds of other things. I can get the start, right, the index character start of where the match begins and where the match ends. I can get a start and end for the span. I can get the regular expression pattern itself. I can look at the string. So there are a number of things here in the match object that I can look at. Caution here, same idea. What the match object returns to me when I call different methods is different, and so just remember that. So sometimes I'm going to get a string. Sometimes I might get a tuple, and a tuple, remember, is immutable. I can't change that. Sometimes I might get an integer. That makes sense. Where does it start? Where does it end? That's going to give me a number. So take a look at what this returns. And if you need to make a little handy cheat sheet or write it down in your notes, that's great. One last thing before we go on here. We can send to the regular expression object, if I scroll back up here again, when I compile my regular expression object, I send it at least one, but maybe two or more things. It is absolutely necessary that I send to it the regular expression string. Again, something I might be craft in regex 101. But then in square brackets here, and the square brackets signify optional data, I can optionally send to the compile method a series of flags or switches. Let's scroll down and look at those here for just a second. There are a bunch of them, but these are the ones that you'll see the most commonly. I can either do an re.I or re.ignore case, and that tells the regular expression to match both uppercase and lowercase letters equivalently. That is to say, cap A to Z is the same thing as lowercase a to Z. I said in the last video that regular expressions are always case sensitive unless I specify otherwise. And this is how I specify otherwise. Now, these other ones I'll let you take a look at. You can match multi-line stuff, which means that it will go across new lines, etc., etc. And there's a .all one here, and I'll just let you take a look at those in the end. Here in regex 101 is where we left off in the last video. We were searching this target text down here for mentions of dogs and or cats. Here is the regular expression that we crafted, and again, we'll just read through this. This creates a group. It is the first set of left parentheses, so it will be group number 1, and that captures a digit, one or more, and as many as possible, followed by a literal space, followed by an alternation. And we have to put alternations into groups. So this becomes a second capturing group, but we might not necessarily want that. We may not. This matches either CAT optional S or DOG optional S. And again, that goes into group 2, but I think group 1 is what we're going to be most interested in. So regex 101 is very helpful because this allows us to craft that regular expression and then move it into Python. So that's what I'm going to do. I'm just going to copy this and we're going to paste it into our text in Python. All right, so let me hide the browser. Over here in the Python interpretive shell, I've already taken the liberty to create my target text. This is just the text we were looking at over in regex 101. I put it into a variable called target. The other thing, of course, now that I need to do is to import the regular expression module. That's import RE. And now what I can do is that I can create a regular expression object, which I will do, by calling in the RE module the compile function, and then I send it some data, which we'll do here in just a second. So what I'm going to do is create a string, and I'm going to paste that regular expression into my string. I'm just going to put a little extra space here at the end so you can see what's happening. So I'm sending that string to the recompile method. Now, one of the things that I do in Python is that I get rid of that space here. I make my strings into raw strings by prefacing them with an R. The R just goes immediately in front of the quotation marks. So why do I do that? Well, we already know that in Python strings will look for these backslashed characters like T's, backslash T for tab, or backslash N for a new line. So if I just create a string, I'm just going to call it S, and I say, oh, this is backslash T, backslash N, hello, backslash N, right? And I print out, if I print S especially, you can see that I get all of those backslash T's turn into tabs, all of those backslash N's turn into new lines. So Python does this conversion automatically. But R says to Python, don't do that. And because regular expressions are going to have so many backslashed characters, I just want to tell Python, don't bother with any of these backslashes because I'm not using them in the way that you expect, because things like backslash D are going to count as classes in regular expressions, so don't bother. So I am in the habit always of just creating raw strings when I work with regular expressions. So that's what I've done here, and that's what the R does. So regex now is an object, and I can even ask regex, hey, what is your pattern? There is my regular expression pattern, just as I sent it. You can see that it gets this escape down here, right? So Python understands how to handle that string. Now, what I'm going to do is I'm going to create a list of matches. And what I'm going to do is I'm going to ask the regular expression to find all of those pattern matches in my target string. And if I ask it what matches is, you can see that this is a list because it is in square brackets, but it is a list of tuples. And those tuples match the two groups that I have created. So again, group 1, because it's the first left parenthesis, becomes the first or the 0th element in that tuple. Group 2 becomes the second or the 1th element in that tuple. So if I would like to add up how many cats and dogs there happen to be, I can write a little loop to look through matches and to add the 0th element of every match. Now, you're probably already a step ahead of me. You will notice that these are strings, right? Well, that makes total sense because regular expressions are string pattern matching templates. So if I send it a string, what I get back is going to be a string. So if I want to add these up, I will have to cast these into an integer. That's easy enough to do. So I'm just going to say for m in matches, no, actually I'm not. Total first. The total number of animals is 0. Now let me do that for m in matches. What I would like to do is to say the total equals the old total plus the integer of the 0th element in m. So there are 11 animals in that text. Let's come back to our puzzle about facetious. So one of the things that I do when I start to craft the regex is that if I know some of the text that I want to match, I'll actually paste that into regex 101, and then I will start replacing the pieces that can vary. Now, in this case, what I'm really interested in are those letters, obviously, right? The vowels A, E, I, O, U. And so that's the part that will remain. Those will become literal matches, and the rest of this will either be ignored or will turn into meta characters. So for example, because the regular expression match slides along the target text, I don't need to account for anything that occurs before the letter A, before the thing that I'm really interested to find. And similarly, I don't care what happens after the U. So the letters that are before and after my particular match are actually irrelevant, and I don't need to take those into account in my regular expression. So really what I'm looking at is this string. And of course the vowels are the ones that are going to remain. That C and that T I'm going to swap out for other meta characters. Now the classic way that I can do that is just to replace that with a dot. Remember, a dot means any character whatsoever. So it could be an A to Z letter, it could be punctuation, it could be all kinds of other stuff. And that's totally fine. If you want to put A to Z's in here, that's okay. But the dot is very, very neat and tiny and compact. So that's one way that we can get rid of that C and that T. Now you might expect, because a C and a T exist, that these are one or more occurrences of any character whatsoever. But that leaves me a little bit problematic when I get out here to the IOU, right? Because there isn't any character between those. So a better representation here would be any letter, any number of times, even 0. So the star is a better meta character for me here than the plus sign, because any letter 0 times matches that IOU pattern in facetious. So in fact, this is the regular expression as I would craft it, right? A followed by 0 or more of any character, followed by an E, followed by 0 or more of any character, I followed by 0 or more of any character, O followed by 0 or more of any character, ending with a U. And again, just to repeat, I don't need to take into account anything that happens before the A or anything that happens after the U. So let's look at a little Python here, and then we can do this in the command line. So again, I'm going to have to import the RE module, and what I'm going to do is to compile my regular expression, and here's my AEIOU pattern match. And I'm going to put that now into a variable called vowels. Now we've seen this before in some other lectures where Python doesn't really have the concept of a constant. So vowels is just a variable like any other, but I sometimes put my regular expression objects into a capitalized variable name. And what that does is it tells me, hey, don't mess with this. You've created this thing. It is an object. It's a regular expression object. Just leave it alone, right? And so if you like that pattern, go right ahead and do it. If you don't, that's okay. And again, just to repeat, the prefix here, that R, tells Python that this is a raw string. And that helps Python to accommodate all of those backslashed character classes and other things that you'll often see in a regular expression. Now, it's true, this one isn't problematic, so that R is kind of optional, but it is a habit of mine always to use an R when I'm creating a regular expression. And then what I'm going to do, right, is open a lexicon, and I'm just going to build that into a giant list. We've seen that before. But then what I'm going to do is to use a loop to move through that list of words, and I'm going to try to apply that regular expression match to each of the words in that loop. So, as a part of my initial status, I know that my vowel words are going to be none. I have none right now. None right now. There are no words that match the AEIOU pattern. So what I'll do is I will iterate the list of words, copying each one in turn into a throwaway variable called word. Again, there is no semantic relationship between the singular and the plural here. So I could say for banana in words, and that would be totally fine. Python is not going to get confused. And then what I'm going to do is I'm going to apply the vowels regular expression pattern to that word. And if that is true, I will append that word to my empty list. So as I work through the list, I am accumulating a list of words that fit that pattern. Now remember, if vowels dot search, right, if my regular expression search method matches, I get a match object in return. And so that is, according to Python, truthy. If I don't have a match, the regular expression will return none, and that is falsy. So the Boolean expression here might look a little weird because I'm not comparing it to anything, but I am not going to do anything with this. I'm not extracting any groups. I'm not doing a split. I'm not doing a substitution. I'm not doing anything with it. So all I need to know is, do I get a match object or do I get none? And that is enough for a Boolean test. All right, here in the interactive shell, I've already gotten started. I have imported the RE module, and I have opened the lexicon and read that into a list of words. Now I'm ready to create my regular expression object, just like I did. Here's my AEIOU, and I can see I have a mistake here, so I'm going to fix it. There you go. Good thing I didn't hit that yet. All right, so I'm going to create my regular expression object, and it's in the vowels capitalized variable there. So what I'm going to do is I'm going to create vowel words, let's make that plural, as an empty list. And what I'm going to do now is I'm going to go through that whole list for word and words. And I'm going to say if vowel search in that particular word happens to be true, again, truthy rather than falsy, then what I would like to do is to append that word to my vowel words. And if I look in vowel words, you can see there are all the words that match that A-E-I-O-U pattern. And so you can see that the meme is actually false because there are a bunch of these words, including things like abstemious, all right? Here's our friend facetious. Sacrilegious is in here as well. Adventitious. So there are some really good words in here. If I look at an even bigger lexicon, then I will get even more of these. So this is our quote-unquote small one of 110,000 words. There are a lot, believe it or not, a lot of scientific words that match this A-E-I-O-U pattern. But what's important about this is that meme is false, and we can use regular expressions in Python as a way to figure that out. All right, let's think our way through a second technique. We used a loop the first time through, but if you've been paying attention to the videos, we've also used the filter function as a way to move through a list and to extract things that match a callback function. So let's do that with a little tiny callback function. So what I'm going to do instead now, all of this other code is the same, but we can do this in one line. So I'm going to extract all of these vowel words. And what I'm going to do first is to create a little tiny lambda function. And so the lambda function is going to take W as an input, and I am just going to send W to the search method of my vowels regular expression object. Again, what we need in a lambda function here, or in a filter function, is something that returns true or false. And the presence of a match is truthy because that would produce a match object. The absence of a match would be falsy because it doesn't have one. So this fits perfectly the concept of a filtering function, and we can just drop that tiny into a lambda function. And again, W there is a parameter that's local to the lambda function. And so we don't typically use really long variables there. We often use the one-letter variable names to do that. But vowels is in the global space. So remember your function scoping rules. Because vowels is in the global space, our lambda function can use it, but technically couldn't change it. And that's okay. It doesn't particularly matter. Once we set that regular expression object, we just want it to stay the same. So then what I do is I send that lambda function to the filter function. And remember, filter needs two parameters. The first thing it needs is a function of some kind that is a Boolean function, returns true or false. That could be a named function, but here obviously we've written it as a lambda function. And the second thing is a list to apply that function to. And here, of course, that is our list of words that we've loaded from our lexicon. Filter then, again, returns a filter object. And so I may want to cast that into something else. So here, if I want to change that filter object into a list, then what I will do is cast it to a list at the last possible step. Now, is that necessary? Maybe not. A filter object is iterable, so I could put that into a loop. But here, for example, I'm calling the length function. I want to know how many words are in there. So filter objects have no len property. So here, if I want to know just how many there are, I do in fact need to convert that into a list so that I can send it to len. But this is how I could do that all in one line by using the filter function and sending to filter a callback function, which is a little tiny lambda function. So I'm going to leave that one to you. You can work on that one on the command line. Now, here are a couple of ideas you can extend this to if you'd like to play with this a little bit more. We were looking for vowels in the ordered pattern, A-E-I-O-U, but you might want to search for vowels that exist in a different pattern rather than alphabetical. So here's a little bit of a sort of pseudocode way that you could approach a project like that. Is that I'm going to take that string, A-E-I-O-U, convert it into a list, and then I could use the random module to shuffle that list into a random order pattern, and then convert that back into a string that I can send to recompile, and then look through my lexicon. So, in other words, scramble or shuffle the list of vowels, and then look for that new pattern. Here's a second one that you can do. Now, the reason that I mentioned this one is because regular expressions may not be your best solution here, but it is a question that would logically occur after we've done an exercise like we have, which is to find words that do contain all 5 vowels, but in which those vowels can occur in any order. So we want to find the words that contain all of them regardless of the order in which they occur. Now, regular expressions is probably not the best solution on this one because regular expressions assume an ordered sequence of characters. So you would have to write a different regular expression, right, for every possible combination of those letters, and that's just a little too far for us. So here's what I would do, how I would handle that. It's an interesting puzzle to work on, and it gives you some practice with Python. So using def, I would write a function, a Boolean function, right, one that just returns either true and false, and I would check to see whether all of A and E and I and O and U happen to exist in that word, right? So def takes as input one word, and it returns as output either true or false, depending whether all 5 of those vowels are in there, regardless of the order. So that's going to be a kind of an if or an if-else or just a series of ifs in conditionals. And again, the in operator, or maybe not in, might be incredibly helpful for you. And then once you have that function as def, you can put that into a loop, but then I would try that to send that to the filter function as a callback and see if you can work with the filtering operation rather than a loop as a way to figure out which words fit in there. All right, well, that's as far as we're going to go today with this regex coding exercise. So I hope that explains to you a little bit about how we can use regular expressions in Python, and even has given you a couple of little sample exercises that you can work on your own. Thanks.